Alright, so in this particular video, we have two spherical balls are placed so that their centers are 5 meters apart. It says the force between the two balls is 4.2 times 10 to the negative 10 newtons. Part A wants us to find the mass of each ball if one ball is twice the mass of the other ball. And then part B asks us how would the force between the balls change if the distance is quadrupled to 4r. So in this particular diagram, we have two spheres here, one on the left, one on the right. And as you notice here, the force of attraction is pointing towards the center because, it's equal in magnitude but opposite in direction. Here, the distance from center to center in this diagram is already given us r, so we don't have to do any extra thinking. All right. So the one thing I do want to point out in part A is though, say what is the mass of each ball if one ball is twice the mass of the other ball. Now sometimes folks have a hard time interpreting the statement, but essentially what it's saying is, look, make mass one of the mass whatever you want, but whatever it is that you make, the other one is twice as much. So to make it easy, I'm just going to call the left one m. If the left one is mass m, then the mass on the right would have to be 2m. So hence twice the mass would imply that whatever mass you make if this is 2, then this would be 4. If this is 3, then this would be 6. You just have to multiply. But to keep the ratio the simplest, I'm just going to call the mass on the left side m, and I'm going to call the mass on the right side 2m's as stated. And then from here, I'm just going to apply it into Newton's gravitational law, and then the function is f of g is equal to capital G. And here m1 is just m, so according to my diagram, the mass on the left, or the spherical ball on the left, I'm just going to call that m, which I have in parentheses there. And then on the right, the mass is 2m, so I'm just going to use 2m for the second spherical ball. So you notice here, all I'm doing is then I'm just applying the function. I don't know what m is, it doesn't matter. That's what we're trying to find. I don't know what 2m is, but 2m is just whatever quantity is represented by m, which we have to find. All right, and then r square here, the diagram has it r square, or excuse me, as r, the distance from center to center, so I'll just use r in this particular problem. So I'm just going to go with the flow here and use the variable given in the diagram. All right, so let's go ahead and simplify this function a little bit. Keep in mind that we're trying to find m, so it's important that you listen to the algebra carefully here. The first thing I hope you notice is that we have an m times 2m. These quantities are separated by two sets of parentheses, so therefore the operation here is to multiply. So m times 2m is 2m squared. Okay, so the common error is that folks might think m plus 2m. That's a mistake. This is m times 2m, therefore it makes it into 2m squared. M times m is m squared, and then the 2 coefficient remains. All right, so I kept the g in the front. I simplify m times 2m to 2m squared. The denominator remains the same as r squared. So in order to solve for m, the first algebra step I need to do is get rid of this r squared in the denominator. So I'm just going to move it up to the left side by multiplying both sides by r squared. All right, so that's the first algebra step. But you notice here, in this particular step, I don't have m by itself yet, right? I have a g in the front. I have a 2 in the front. I have an m squared. So in order to get m squared by itself, I need to divide both sides by capital G and 2. So I'm going to divide g and 2 at the same time. So which is the same as moving capital G into the left side, and that goes in the denominator. Likewise with the 2, that also goes in the denominator. So here we have a statement, f of g times r squared divided by 2 capital G, which is equal to m squared. And hopefully by now we can just plug values in. F of g in this problem is given as 4.2 times 10 to the negative 10 newtons. So that's where that value in the first parentheses come from. R is given in the statement. It says their centers are 5 meters apart. So here is 5 meters. I want to square that because this is r squared. So don't forget the square. And then the 2, that's just part of the function in this particular problem, because again, m times 2m gives you 2m squared. So that's where the 2 comes from. And then capital G is the gravitational constant of 6.67 times 10 to the negative 11 with all these units behind it. Here, I'm just going to cancel out units just to help clean things up a little bit. Newtons will cancel out. And then meter, I do want to point out that there is a exponent outside of this second parenthesis. So really it's m squared, because when you distribute the 2 to the 5, it makes it 25. and then you need to distribute the exponent 2 here to the m, what makes the m square, and that m square is going to cancel with this m square on the bottom. So the only units we have left here is kilogram square, which makes sense because we're trying to solve for mass, which has units of kilogram. Okay. So therefore, in order to get m by itself, we need to square root both sides. So if you punch all this stuff here on into your calculator, you should get a value of 78.71. But then now we need to solve for m by square rooting both sides. So therefore, the square root of 78.71 will give us a value of about 8.87 kilograms. So that is the mass of just a smaller mass. Okay. Therefore, I want to point out what you need to interpret is this. Part A says, what is the mass of each ball? Well, I just found the mass of m. So m is equal to 8.87. So therefore, that's the first mass. Well, the mass on the right is 2m. So you would just put in 2 times 8.87 kilograms. So that would be the mass of the second one. Okay. So the mass of the second one is just 2 times 8.87. All right. So those would be your two answers. Let's do part B. Part B asks us how would the force change if the between the two balls if the distance quadruple? Quadruple would imply that you're multiplying the distance by 4, or you're making the distance 4 times as far. Okay. As usual, I'm going to start with my chart here, before and after. The original function is given as g m1 m2 over r squared. But here, m1 is just m, m2 is 2m. So what I did was I substitute out the generic function m1 for just m, because that's what I've chosen. m2, I don't know what it is. I'm just going to call it 2m. And then here's r squared. The purpose of the part B is not to plug values in. So you notice here I'm not plugging numbers in. I'm just kind of going with the flow, and I'm substituting it for variables that is presented in the diagram. Okay. Cleaning this up a little bit, m times, again, 2m is 2m squared. So this is what f of g looks like. Okay. Now that we have a generic function for f of g in this particular problem, we can go ahead and clean it up a little bit using the right side of the chart. Well, the right side of the chart asks you, how would the force change? Well, here I have fg new. G stays the same. The mass stays the same. The 2m stays the same. The only thing that has changed in this one is that the distance is quadrupled. So instead of r, I'm going to replace r in the denominator with the parentheses for r squared. I like to tell folks that it is important that you use parentheses here, because otherwise you will not distribute the square, and that's going to cost you a lot of headache. Okay, so use parentheses when you substitute in the denominator. It will help you, and it will help prevent a lot of errors. Here, because the 4r is in parentheses, each of those terms is going to get the exponent. So you need to distribute the exponent 2 to the 4, but you also need to distribute the exponent to the r. So in that case, numerator stays the same. It will be g 2m squared. Once again, m times 2m is 2m squared. 4 squared is 16, and then r squared is r squared in the denominator. From here, you notice that the 16 is in the denominator, so we can pull that out front just to help you visualize things here. If your math is really good, you don't need to do this step, okay? The only thing different here in this second line and on this line is the 16 in the denominator. So you're dividing by 16, which is the same thing as multiplying by 1/16. So you notice I just pulled the 16 out on the front and make it into a 1 over 16 just to make it look nice. And then if you've seen my first couple of videos, what you essentially do is recognize what is the same on both sides and substitute. Here we have g times 2 times m squared divided by r squared is f of g. Therefore, I notice here we have the same term, g times 2 times m squared divided by r squared. So therefore, I can replace this whole entire box with f of g, because that's what it equals to. So therefore, I have 1 over 16 times f of g. 1 times f of g is just f of g, and then 16 in the denominator just carry over. So you can stop here in the middle if you like. You can say it's 1/16 of the original f of g, or you can rewrite it as f of g divided by 16, which is the same thing. So it's 1/16 of the original function, and that is because Newton's gravitational law is inverse square law. Inverse square law implies that if you quadruple the distance, your force actually decreases by a factor of 16, assuming you don't change any of the masses, which in this case was not changed. Okay. All right. Other than that, the answer for part B is f of g divided by 16. All right. I hope that helps. Stay nerdy. Don't be whack.